Alright, in this tutorial we'll be implementing some security features, that is Inspector. So Inspector, we know that is associated with EC2. This is me as the user will try this hands-on first to clarify this concept. The agenda of today is to implement Inspector in an EC2 instance. Will be also be able to download the PDF associated with any kind of security risk with respect to the EC2 instance which we have created. So let's now dive into the hands-on. Alright, we are at the AWS console, so let's start everything from the scratch. We'll go to EC2 because Inspector is associated with EC2. Let's first spin up one instance. We'll click on launch instance. Let's name it EC2 Cloud Guru Amit. Let's scroll down a bit. We'll keep everything as default. We'll use Linux instance. Please note that we also want to SSH into the instance. So if you have missed my tutorial, then you can navigate where I've explained SSH because it's an advanced tutorial. So let's now create one key pair. So let's name it EC2 Inspector. We'll create one key pair. Yeah, so the key pair is done. We need the key pair in order to SSH. So next we need to make sure that auto assign public IP is enabled because we want to SSH. Also now allow SSH traffic from anywhere because we'll be using our this computer. So let's select specifically, like, let's create some trouble for us. So the trouble will be purposely doing some kind of opening the ports. So we know that opening ports which are not required is a security issue by itself. So that's what we are doing, and that's what we want Inspector to detect. So let's check those things. So I'm opening, let's say I'll randomly open port 21, 22, 23. I'll select anywhere. Please note I'm doing it purposely. Do not try to do this in your real projects or on your like office, otherwise you'll be having tough time in your office to explain this. So let's create this instance now. So we are almost done. So it's launching our instance. It takes some time. So let's dive into the architecture diagram where we are. So this is me. I'm using the console. I've created one EC2. So now next step would be to install the Inspector agent, because unless we install Inspector agent, Inspector AWS service cannot work there. So we need to SSH and install using the backend. So let's do it now using EC2 instance connect. So let's go back. Since our instance state is running, so we can now SSH definitely. So let's click on connect. So let's now scroll down. We have the connect button here for the EC2 instance connect. So we can use EC2 instance connect to directly connect to it, or you can use PuTTY or CMD as well. So let's do sudo su. So I have kept the commands handy. So first will be in order to install, we need to first download the agent. So let's do it. So let's paste it. Yeah, so we are done. Let's do a curl on it as well to showcase. Yep, so this is also working. Now next step would be to install, right? So let's now install it. So yep, we are done with installing. So now let's duplicate this tab. We are done with let's go back to the architecture diagram. So we are done with this part, Inspector agent installing this thing. Now we need Amazon Inspector. We'll be creating some assessment templates and all, and finally the report. This is our end goal. So let's go back. Here we'll type Inspector, and before going here, so let's also check give you the instance ID is something 829, just remember the last date, and public IP address maybe also be required. So we'll be using the classic console. So let's switch to classic. So let's click on get started. So let's cancel this, we don't need it. So the first thing is to create assessment target. So what is assessment target? Since we need to make sure like our EC2 instance is the target. So currently this is our target, this EC2 instance. So that's what we are doing. We'll be creating one target. Click on create. We need to name it like EC2 Cloud Guru assessment, any kind of. So we'll include all the instance. I currently have only one instance, so it doesn't matter for me. It will automatically include all instances in this AWS region. So let's save it. So once it's saved, we can check it as well, this thing. So we can also preview the target, like which EC2 instance is targeted. So if you look here, this is the public IP. Let's match it. Here is also the public IP. If you look, also if you want to check the ID, it's something 829 as mentioned. See, this is the same ID. So we are targeting the EC2 instance. That is we are on the right track. So that's how we know. So we are done with the assessment target. So now go ahead with creating one assessment template. So templates are nothing but some predefined rule. I'll name it EC2. So there are already some, this is our assessment which we have created in the previous step, EC2 Cloud Guru assessment. So there are some predefined rules as well which AWS provides. So we can use the best practices. I'll select all. So if any of these are breaches, so that will be reflected in the report. So let's create 15 minutes report. What I mean by report is the PDF report. So that will be reflected in our PDF report. So let's go back. We don't need SNS or anything. This is just a simple kind of demo. So let's now click on create. So it's almost on the progress. So assessment runs. Since we haven't run any kind of assessment now, so let's select this under assessment template. Let's select and click on run. So we have seen assessment has started, success. So under assessment runs, it should pop up. Yep, it's popping up. So it takes some time for the assessment. It currently you can see the findings are 0. It will populate to some findings because we have purposely opened some of the ports as mentioned, because you might remember that we have while treating the instance, we have purposely opened port 21, 23, 24, these all things from anywhere, can access. We don't want to open unnecessary ports as one of the best practice. So let's check whether inspector can detect or not. We need to constantly refresh it. So see, currently the findings are 4. So I think we are good to check the report. So here is the download report button. Here in the below also, you can check everything, but it's not much descriptive way. So let's click on the PDF. I'll generate in PDF format. Findings, I'll just generate the findings report. Click on generate report. So it opens a new tab automatically, and the report and the findings will be listed. So let's check what it does. So this is the assessment report on specific time, what we see. So let's scroll down a bit. So we can see the executive summary of it, like assessment, the keys for the EC2 tags are defined, those things it's mentioned. Let's scroll down a bit more and check. And we have successfully implemented this architecture diagram related to EC2 and security concepts with Inspector, the PDF you have got. So you can implement this in your project as well. If there are any EC2 instance, you can use Inspector to check for any kind of security issues are there or not, and let your manager know about it. I hope you found this hands-on helpful. Alright, let's cover some concepts related to EC2 now. We'll first look at option A. Option A says set up auto-scaling groups with C6G 4x large compute optimized instances. So option A is not the best choice for a game that has shown to consume only a quarter of the expected CPU and memory. If you look here, only 25%. Compute optimized instances are ideal for compute bound application and do not provide the cost effectiveness for memory utilization that is required as per the question. So this is out. Let's now move to option B. Option B uses M6G 4x large, that is of general purpose type. So option B is again incorrect because M6G 4x large instances provide a balance of compute, memory and networking resources. They do not specialize in memory optimization, so which is what the company needs as per the question and as per also CloudWatch matrix if you also look here. So this is out. Let's now move to option C. Option C uses R6G4X large memory optimized. Since the company's game is consuming less CPU and memory than expected, downsizing to a smaller instance size while still choosing memory optimized instances allows for cost savings without sacrificing the necessary performance for memory intensive workloads. So this can be the potential answer. Let's park this. Let's move to option D. D uses R6G 8x large memory optimized. So 8x large instances are large and more expensive. The company does not need such large instances. Instead, since the demand has subsided, if you look here, and the consumption is lower than initially expected. So this is not we require. Let's reject this and we'll log option C as the correct answer. Alright, let's bring the heat to the snow now. We'll look at option A first. A says turn on the application load balancers access logs and direct them to an Amazon S3 bucket for storage. Enabling access logs for ALB and storing them in an S3 bucket will capture the logs related to the load balancer's activity, not the application logs from EC2 instances. Hence this is incorrect. Let's move to option B. B says set up the EC2 instances to send logs to Amazon CloudWatch logs using the CloudWatch unified agent. So configuring EC2 instances to publish logs to Amazon CloudWatch logs using the unified CloudWatch agent allows the logs to be retained and accessible even after the instances are terminated during a scale-in event. This can be the potential answer. Let's park this. We'll look at option C and D together. C says change the auto scaling groups policy to a step scaling approach. D says implement AWS X-ray tracing within the application. So these options doesn't address the retention of the application logs after instances are terminated. That is what we require as per the question. So this is out. We'll log option B as the correct answer. Okay, we have quite a long question this time. Reading this can be a bit difficult and we need to mark the keyword especially whenever the question is long, right? So as to shorten or narrow down where we need to focus. So we'll first look at option A. Option says, if we look at the first line, set up 3 NAT gateways. We know that deploying 3 NAT gateways is unnecessary and costly. Second, the most important thing is it's costly. Another important thing is that assigning the same elastic IP address to multiple NAT gateways. If we read this statement, these gateways, that means NAT gateways, it is not possible or not feasible. So this is definitely not valid, right? So A is out. Let's move to option B. B says swap the ALB for a network load balancer NLB. And also it says assign the elastic IP to the NLB. NLB are used for different purposes, we know. Typically we need static IP addresses for the load balancer itself. In this scenario, the application load balancer is required to distribute incoming traffic across multiple EC2 instances, and the elastic IP address is needed for the NAT gateway and not the NLB or network load balancer. Therefore, incorrect choice. Let's move to option D first. D says attach the elastic IP to the ALB. So assigning the elastic IP address to the ALB or application load balancer is not possible because application load balancer cannot be assigned elastic IP addresses. Hence, incorrect choice. We are left out with option C. So option C is the most suitable because it involves deploying a single NAT gateway. If you read here, single NAT gateway in a public subnet and assigning the elastic IP address to it. This setup will allow the instances in the private subnet to initiate outbound traffic to the internet or on-premises systems while preventing unsolicited inbound traffic. Additionally, if you look, using CloudWatch with custom metric to monitor the NAT gateways, health ensures that any failure can be detected and mitigated automatically. If the NAT gateway becomes unhealthy, an AWS Lambda function can be invoked to create a NAT gateway in a different subnet and reassigned the elastic IP address, ensuring high ability and automatic failure mitigation. That's what is required. We'll lock option C as the correct answer. Alrighty, let's look at this question. We'll first look at option A. Option C is set up Amazon Event Bridge to trigger an AWS Lambda function. So configuring Amazon Event Bridge to invoke an AWS Lambda function adds complexity and requires additional steps to manage the Lambda function and its permission. Therefore, incorrect choice. We'll move to option B. B says develop a script to halt means to stop Amazon EC2 auto-scaling activities. So writing a script to suspend and resume auto-scaling operations introduces manual steps. And manual steps, in our day-to-day activities is the enemy, because manual steps, if we use, it can lead to human error as well, right? Which we don't want, especially in the production environment. And also, if we add manual steps, it will also cause some potential downtime, which is not ideal for the application as per the question that needs to be live in less than a day, right? As per the requirement of the question. So this is incorrect choice. Let's move to option C. C says destabilize a new AWS code built project to produce an AMI with the updated code. Creating a new AWS code build project to create a new AMI and updating the autoscaling group's launch template is a valid approach, but involves more steps and complexity compared to using a predefined AMI with the code deploy agent already installed. So we'll reject this. We are left out with option D. Option D is the most efficient because it automates the process of installing the code deploy agent on new instances by associating the code deployment group with the autoscaling group. Any new instance that comes up as a part of the autoscaling group will automatically have the code deploy agent installed and be a part of the deployment group. This eliminates the need to manually install the code deploy agent on new instances, thus reducing the operational overhead as required by the question. We'll log this. Alright, let's look at this question. Seems interesting. We'll first look at option A and C because both start with the some same words. Option A says remove the current application load balancer, and C also says remove the current application load balancer. We are not reading the entire options because that is what we need to even eliminate. So deleting the existing application load balancer is unnecessary and it will increase the downtime. It is not the desirable solution because as per the question, we need to minimize the disruption if you look here. So these are incorrect choice. Let's move to option D. If you look at option D, option B and D, if you look, are almost similar, but option D is incorrect because it suggests, if you read here, await the registration of the existing EC2 instance with auto-scaling group by the current TLB. So if we await or wait for the existing application load balancer to register the existing EC2 instance with the auto-scaling group, it will, however, the registration of the instances is handled automatically by the auto-scaling group, making this step as redundant. Waiting for application load balancer to register EC2 instances will cause delay. We need to also minimize the delay as well, right? We don't want unnecessary wastage of time to wait for something which we don't require. So hence this option is incorrect. We'll lock option B as the correct answer. So please don't go away.